Greetings, Spartan fans. Today we are going to talk about properties of exponents, section 6.3 and 6.4 in the book. So some of this I hope, actually most of it I hope, is review for you from Algebra 1. And rather than go through every single property that you need to know, I'm going to direct you to page 237. And at the bottom of page 237, there's all the properties: quotient property, product property, etc. So I would encourage you to copy that table into your notes. Okay. And so I'm just going to go right to a few examples about adding exponents, subtracting exponents, etc. Okay, so example 1. If I ask you to do something like 2x to the 4th times, how about 7x squared squared? All right, so everything in the parentheses is going to get raised to the 4th power. It's not just x to the 4th, it's also 2 to the 4th power. Be careful, that's not 8. And it's not just the x squared that gets squared, it's 7 that gets squared as well. So this is going to turn into 16x to the 4th times 49. X squared squared is x to the 4th power. And then we're going to multiply 16 times 49. And I'm going to grab my calculator here. 16 times 49. And that's going to give me 784 x to the 8th power. All right, let's throw in some fractions. So let's do something like negative 3x squared y to the 4th. How about, let's multiply again, actually. Let's do times negative 2xy to the 5th. And how about we do that to the 3rd power? Okay, so my recommendation, parentheses and exponents come first. So take care of the quantity that I was circling. So negative 2 cubed is negative 8. X to the 1st cubed is x cubed. Y to the 5th cubed is y to the 15th. That is the power property. And then we're going to multiply that by negative 3x squared y to the 4th. Okay, now we're going to multiply the coefficients. This becomes straight out negative 3 times negative 8. So that's going to be positive 24, add the exponents, x to the 5th, y to the 19th. And there you have it. Okie dokie. When you have a fraction that is raised to the power, so if you have something like, let's say, how about 12x to the 12th, y to the 7th, over, how about 3x cubed y squared, and that whole thing is raised to the 4th power. Okay, keep in mind parentheses first. I do not want to do 12 to the 4th power and then divide that by 3 to the 4th power. Let's take care of the exponents inside of the parentheses first. So this is going to become 12 divided by 3 is 4. X to the 12th over x to the 3rd. You've got 12 x's in the top, the numerator, 3 x's in the denominator. You subtract and you get x to the 9th. And then y to the 7th over y squared is y to the 5th. And now I'm going to take that and raise it to the 4th power. Be careful, 4 to the 4th power is not 16. 4 to the 4th power is 256. And then you get x to the 36th. Multiply the exponents, y to the 20th. And those are your basic properties of exponents. Okay. I'm going to move on to section 6.4, which is all about rational exponents. Rational exponents are going to be super, super, super important. I say that about everything. A rational exponent. Rational fraction. Okay. All right. Here we go. Fraction exponents are always some type of root. Okay, here we go. You have x. I think your book uses a and b. I like to use m and n. You have x, and it is raised to some fraction power. This is the nth root of x to the m power, which is the same thing as the nth root of x to the m power. So I would get out my highlighter and I would highlight this. Okay, and then there's going to be some vocabulary that goes along with this. The n is called the index. It's also the root. Okay. And what is under the root? So the x is referred to as the radicand. What is under the root is called the radicand. It's a radical. So first, let's just practice going back and forth between the forms. Okay. So x to the 2/3 power. The denominator, 3, is going to become my root. The denominator is the root. The numerator is the exponent. This is exactly the same thing as the cube root of x squared. Both of those are correct. Okay. Very common to know is square roots and cube roots. Square root. Okay, so square root of x. All right, you've seen that before when we've graphed it. All right, well, we don't write it, but this is indeed the same thing as the square root of x to the first. I mean, we don't write the 1 or the 2, but it is the same. A square root is the same as a 1/2 power. The denominator, 2, is the root. The numerator is the power. So square roots, very, very common that we're going to be converting that to x to the 1/2. And then a cube root is going to be to the 1/3. So a cube root is x to the 1/3. Okay. Okay. So that's part of it, rational exponents. And then let's talk about negative exponents. Negative exponents. Flip and make the exponent positive. Take the reciprocal and make the exponent positive. So if you have a fraction to start with, so if you have, let me write this out here. If you have, let me erase this. Let me add in something else. If you start with a fraction, like x over y to the negative m, That is y over x to the positive m. And that is negative exponents. That's a terrible color. That's a little bit better, I guess. I shouldn't be writing in orange, huh? Okay, so let's do some practice with negative exponents and fraction exponents, etc. All right, so let's simplify. All these problems we're going to simplify. So let's simplify something like x to the negative 5 y cubed over x squared y to the negative 4. All right, we're going to look at each individual variable. So x to the negative 5. It is negative in the numerator. I am going to move it down to the denominator and make it positive. So it was negative on top. I made it positive on the bottom. Y to the third, can't do anything with it. I'm just going to leave it as y to the third. I have x squared. It's positive 2. I'm not going to move it. I'm going to leave it right here as positive 2. But y to the negative 4, it is negative in the denominator. So when I flip it, I'm going to bring it up to the top and make it positive. Negative exponents move, positive exponents stay the same. The answer to this is y to the 7th over x to the 7th. Okay. My favorite kind of problems have all kinds of negatives and positives, etc. mixed in. Let's do something like, let's do like some double negatives. How about you have like 2, let's do negative 2. X to the third, y to the negative 10th, all over 3x to the negative 1, y cubed, and I'm going to raise all of that to the negative 2 power. Okay, you have options. You have options. You could take care of the negative 2 on the outside and flip what's inside and make this a positive 2. I tend to look at what's inside and simplify that first. So I'm going to temporarily ignore the negative 2 outside first. Okay. Inside. Negative 2, it's a coefficient, not an exponent. Don't move it. The negative 2 is a coefficient. It doesn't move. Y to the negative 10, it's negative. Move it down to the bottom and make it positive. This 3 doesn't move. Y cubed doesn't move. X to the negative 1, that's going to move. So I'm going to leave the 3 alone. And I'm going to leave the y cubed alone. And I'm going to bring x to the first on top. And that whole thing is going to be raised to the negative 2 power. I'm going to simplify what's inside. Now I'm going to end up with negative 2x to the 4th over 3y to the 13th to the negative 2 power. Okay, so I have completely simplified the inside of the parentheses. I can't do anything more to that. Ms. Babiak, why didn't you move the negative 2 to the denominator? Because the negative 2, that's not an exponent. An exponent is a power. This is a coefficient. Now I am going to flip. I'm going to make it 3y to the 13th over negative 2x to the 4th, and I'm going to square that. I flipped, and I made the exponent positive. This is now 9y multiply 26 over 4x to the 8th. Notice I didn't square the 13. That's not 169. I did not square the 4. Multiply 13 times 2, 26. 4 times 2, 8. That is the answer. That's negative exponents. All right, so let's just play around with this a little bit, and let's throw some of those fractions in there as well. Okay. Let's Let's look at some roots and let's look at some fractions. So how about something like, let's do 64x squared to the negative 1/3 power. Okay. Flip, make the exponent positive. So this is going to become 1 over 64x squared to the positive 1/3 power. Flipped, made the exponent negative, or positive, sorry. Now, this is going to become 1 over the cube root of 64x squared. The denominator, the 3, becomes the root. The numerator 1, that's this whole thing to the first power, which you don't need the 1. I know the cube root of 64, there'll be very little calculator on this. The cube root of 64 is 4. Cube root of x squared. And for right now, we're going to leave it that way. We'll worry about rationalizing in the next section. For right now, it's a little bit too complicated. Let's just leave it this way. Eventually, we will rationalize that. Okay. 0 exponents. Anything to the 0 power is 1. Anything to the 0 power is 1, except 0. 0 to the 0 power is called the indeterminate, and you'll talk about that when you get to calculus, which is probably sooner rather than later. Anything to the 0 power is 1. Okay, let's do another one here. Let's do the 5th root of x to the 30th, y to the 32nd. Okay. Essentially, you're dividing exponents. If I were to rewrite this, this would be x to the 30th, y to the 32nd to the 1/5 power. Denominator is the root. Numerator is the power. It's all being raised to the first power. Okay, well, multiply by a fraction, divide. So 30 times 1/5. That's the same thing as 30 times 1/5 is the same thing as 30 divided by 5, which is 6. 32, oh geez, wrong thing. Let's try that again. 32 fifths, okay? That's going to be 32 fifths. Well, I certainly don't like that. That's pretty gross. So off to the side here, 32 fifths. That is 6 and 2/5. Does that sound about right? It's a mixed number, and we all know how much I love mixed numbers. Gross, gross, gross. So I'm certainly not going to leave it that way. So this is going to be x to the 6th, y to the 6th times y to the 2/5. What just happened there? Add exponents. 6 plus 2/5 is 6 and 2/5. This is the same thing as x to the 6th, y to the 6th times the 5th root of y squared. I took it from fraction to root. The denominator 5 is the root. The numerator 2 is the power. I'm going to show you another way to do this that might be a little bit easier for some of you. It depends on who you are. And I don't care which way you do it. I'm going to show you another option. Okay, so another option, let me rewrite the problem. Is to divide. You could say 30 divided by 5 is 6, and that's how you would get x to the 6th. Okay, the other way to do this, and there's not a whole lot I can write down, it's more of a verbal explanation. 5 goes into 32, 5 goes into 32 6 times evenly, so 6 of them get to come out with a remainder of 2. Exact same answer. All right, I'm going to give you one big monstrous problem, and then I'll do another separate video for graphing exponential functions. Okay, so let's do (4x cubed to the negative 2 times, how about 32 y to the 5th z to the 10th to the 2/5 power over x to the 0 y to the negative 2 to the negative 4. Okay. So many ways you can start this. I'm just going to go from left to right. I cannot simplify 4x cubed, so I'm going to hold off on that to the negative 2. I'm going to try and maybe simplify this, or maybe you want to take this whole quantity, it's to the negative 2, and move it down. Maybe you want to multiply the exponents. There's so many options. Okay. Okay, so negative exponent, I would flip and move it to the denominator. Lots of options. So I'm going to take 4x cubed, and I'm going to move it to the denominator and make it positive 2. Anything to the 0 power except 0 is 1. And you'll learn more about that in calculus. It's indeterminate. I know, pretty cool math. And then y squared, y to the negative 2 to the negative 4 becomes y to the 8th. So what happens to x to the 0? It's 1. 1 to any power is 1. Nothing fancy there. Okay. 32 to the 2/5 power. This becomes the 5th root of 32 y to the 5th z to the 10th squared. Oh my God. 5th root of 32 is 2. You'll get really good at that. The 5th root of y to the 5th is y. The 5th root of z to the 10th is z squared, and that's all going to be squared. All right, let's finish this up. 4y squared, z to the 4th, over 4 squared is 16. I hope I didn't make any mistakes. That's the worst part about making a video, is if there's a mistake, I'm not going to find out about it, huh? X to the 6th, y to the 8th. For a total of, Spartan fans, here we go. 4 over 16 is 1/4. If you give me a decimal, please do not give me a heart attack. Y squared over y to the 8th is y to the 6th in the denominator. No other z's, so it's going to be z to the 4th in the numerator, x to the 6th in the denominator. Okay, I am going to make a separate video for graphing exponential functions. The homework is on the backboard. I will be available for tutorial tomorrow if you need any help.